Alright, this is section 8.4 about vectors. So let me leave it there for a second. So I just want to, I'm not going to read through everything, you can read through there. I just want to point out a couple of things. So a vector, the name of the vector can be denoted different ways, as a ray, as a bold-faced letter, or sometimes as a italics letter with a little ray sign on top of it. Okay, so V or W like that. Okay, all right. When you're going to add vectors, this says the sum is formed by placing the initial point of W. This is V plus W. The initial point of W at the terminal point of V. So when you have V plus W, let's say this is V, and let's say this is V plus, and let's say you have W going in some strange direction, let's say that, and notice the length indicates the strength of the vector, right, or the magnitude. So V is stronger than vector W. You're going to place the initial point of W at the terminal point of V, so that means it's going to look like this. There's V, and then W is going to be at the terminal point of V, like so, okay, and this is V, and this is W, and then W plus V is actually this vector, the resultant vector. I'm sorry, that's V plus W, like so. Okay, so that's what's meant by placing the initial point of W at the terminal point of V. All right, and then we have also a zero vector denoted with a boldface 0, or if I write it, because I don't write boldface, I'll write 0 with a little vector or a little ray symbol on top. Okay, all right, so the magnitude is the length. So notice we can find the length just by doing the distance formula, right? So for example, the first one is going to be, the distance is going to be the square root of 3 minus 0 squared plus 4 minus 0 squared. All right, so I'll leave those to you guys. And then for V and W to be equal, don't forget they have to be equal in magnitude and direction, same direction. Okay, let's go on to part 2. Representing vectors in component form. So component form uses these little triangular sort of grouping symbols. All right, and then you have the components, which are the first component and second component. This tells us that if we know the coordinates of the initial point and the terminal point, then we can find the components by subtracting, right? Terminal point coordinates minus initial point coordinates. Okay, all right. And then also in standard position, that they will always be in standard position, right? When they're written in component form, they will be in standard position. So we can think of them as having initial point 0, 0 and terminal point AB. Notice that the coordinates AB with parentheses and the components AB with the triangular little grouping symbols. All right. So by the way, this tells us that if we want to find the magnitude of a vector, and they give us this, that we can think of it as starting at 0, 0 and ending at AB, and just find that length or that distance from 0, 0 to AB. Okay. All right. We'll leave those examples for class. All right. All right. Page 2, part 3 says operations on vectors, and I would like to just point out the operations. The other ones you can read on your own. V plus W, we can add in component form. So we have V in component form and W in component form. Then the sum is just the sum of their components. And the difference is the difference of their components. And if we multiply some real number C times a vector, we can multiply each of their components times C. Okay? All right. The properties you can read on your own. Let's try one of these examples. Given R equals negative 310 in component form and S equals 12 negative 7, find R plus S. So R plus S is going to be the first component plus the first component, negative 3 plus 10, plus 12, I'm sorry, comma, 10 plus negative 17. Notice I'm just adding the first components and the second components, and the sum of the first components is the first component of the sum. Right, that'll be 9, comma, negative 7. All right. And we can see them actually. So negative 310, if we look at the XY plane, negative 310 will be pointing kind of like so, right? And then 12 negative 7 will be pointing kind of like so, right? And so to add them, notice we're actually doing this. We're taking R and adding S, like so up here. Notice we kind of translated up there. And then the resultant is something like that. This is R plus S. In this case, notice it's going this way, right? So it means that it's a little bit longer this way. So I just, my picture's off scale there. It's not really the correct picture. All right, let's go on to, let's do 6A. So 6A, again, we said we just multiply each of the components. So this will be 6 times 11, comma, 6 times negative 7. All right, notice my components, right? This is 66, negative 42. Right, and if I was to look at what A looks like, right, let's say 11, negative 7 looks kind of like that. 6 of those would be 6, right, times the length, like so. Okay? All right. Some other details. So a vector of magnitude, what is called a unit vector. So if V is AB, components AB, then the unit vector U in the direction V is given by use of V equals 1 over the magnitude of V times V. Okay? And then the rest of it is just telling you that, how different ways to represent it. I and J are unit vectors, with I being equal to the vector 1, comma 0, and J the vector 0, comma 1. Notice 1, comma 0, if I look at the coordinate plane, 1, comma 0 is just that way, and 0, 1 is just that way. Okay, so 1, 0 is a horizontal, and 0, 1 is a vertical. All right, if V equals AB, then we can write V as AI plus BJ. And that's just a way of writing the same thing. Notice A is still there, and B is still there. I just denote it in a different way. All right, so let's take a look at example number 1. Says find a unit vector in the direction V equals 5, negative 1. So first we want to find the magnitude. So this vector goes from 0, 0 to 5, negative 1. So its magnitude, notice how I denote magnitude with a double little bars on the sides, will be the square root of 5 minus 0 squared plus negative 1 minus 0 squared. Notice that's just 5 squared plus negative 1 squared. That's the square root of 26. Okay, so I'm going to divide each of these by the square root of 26. Notice that's how we find the unit vector. So this will be 5 over square root of 26, comma, negative 1 over square root of 26. And then don't forget to rationalize. So this will be 5 square root of 26 over 26, comma, negative square root of 26 over 26. There we go. All right, I think I'm going to zoom in a little bit, slightly. All right, and I'm going to leave the other examples for us to do in class. This one, given A, B, and C, and we want to write negative 2A minus 4B, is the same as this one over here, just written in a different way, minus 3A plus 10B. Just the other one, the A's and B's are written with I's and J's, right? But you still have A and B, I'm sorry, first component, second component, first component, second component, right? Same thing as here. First component, second component, first component, second component. Just written in a slightly different way in terms of I and J. That's what it's called. All right, but otherwise it's the same thing. You're just adding components. All right, so one other thing we want to see is relating component to direction and magnitude. So let's say we have a vector with components A, B in standard position, and theta between 0 and 360. The direction of V measured counterclockwise. So that's what we're used to, right? Counterclockwise means like so, right? Counterclockwise from the positive x-axis, and that's the way we've learned to measure angles. All right, so the magnitude of V is the square root of A squared plus B squared. Tangent theta is B over A. That sounds familiar. It sounds like Y over X. A is equal to magnitude of V cosine theta, and B is equal to magnitude of V sine theta. V, therefore, can be written, because A is magnitude of V cosine theta, we can write magnitude of V cosine theta, comma, magnitude of V sine theta, or magnitude of V cosine theta I plus magnitude of V sine theta J. Notice that those are all just different representations of A and B, the components of the vector. Alrighty. And the last one, a man exerts a force of 80 pounds on an object by pulling a rope at an angle of 30 degrees from the horizontal. Write the force vector F in terms of I. And so we would just go this, we're just being asked to use number 4. So this would be the magnitude of V is 80. And we'll leave that one for class. All right. We got a couple more examples to go, but I'm going to stop here. And then we'll pick up on there on the next video.